Hey yo, bet you were expecting with teacher Tandi. As you might have seen on our socials, on Maski socials, we were having an issue with the parabola graph. And today I have with teacher Tandi.
Hey, cauliflower. My children are going to be confused. What is this?
I was going for a parabola graph.
Parabola? Which grade is this? Grade 9? No, in grade 9 we don't do a parabola, but because cauliflower is busy saying that this is a parabola, we need to solve the issue before we run the race of today. Cauliflower, this is not a parabola, it's a box and whiskers. We would learn this when we go to grade 10, but let's teacher Tandi show you what a parabola graph look like, right? Okay, so let's do that. A parabola graph always have to be drawn on a Cartesian plane, just like you did with your box and whisker, right? It has your x-axis. So we always do that when we draw any graph, okay? So let's see, when we draw the graph, we always put the arrows because it's a non-ending lines. But a parabola looks like this. It's either have a smiley face just like that, right? Or it has a curve. That parabola has run away like a cauliflower is busy. Let's do that. Oh, let's do it like that. So there is your parabola graph. It's like a smiley face.
Got that?
Or you can have it as a sad face just like this. Let's use this color. So your parabola graph, right? It's more like a sad and a funny face. You guys today are going to learn about graphs, but we are not going to do the parabola graphs that cauliflower was talking about, and we are not doing box and whisker, okay?
I'm with you.
We see you right now when we do the real graphs of grade 9. Sit tight. Yes, as I promised, today we are going to do graphs, but we are not going to do a parabola graph of our corny boy or cauliflower. We're going to do the graph which we call linear graph. You guys have seen that in grade 9, we have many types of graphs that we do. Yes, we have curved graph, which looks like a parabola, but today we are going to focus only on a linear graph, which we call straight line. We're not going to do the other types of graph, but we're going to focus on this one. Okay, as you settle, remember when we deal with graphs, we are today only focusing on drawing these graphs, that we have been doing the interpretation of graph, how to get the gradient, how to get the x and y intercept. Today only, we are going to then draw the graphs with all this information that we have been learning. Okay. By the end of the session today, you need to be able to know how to use your table of ordered pair, and you need to be able to draw those ordered pairs into the Cartesian plane, those points, and then you draw the graph. So that's what we are going to do. Also, you need to know how to use your x and y intercept, that you would know how to calculate. Just to remind you that when we have an equation of a straight line, it looks like this, or it must look like this, with y equals mx plus c. And you need to also be able to determine the equations, right, of that graph. Just for a reminder, recap from the previous lessons, we did talk about the straight line and we did say that this M represent a gradient while the C represent y-intercept, right? So just to remind you how we calculate the gradient as well. So that's the formula of the gradient. That was the lesson that we did last week. Okay. Also, remember that when you are drawing the graph, you need to recognize or realize your gradient if it's a positive or it's negative, because that one then affects the slope of your graph. So if you see a gradient as, for example, a number 1 or 2 or 5, just like that, then your slope is going to go to the right like this. So you just curve it that way to the right of your side, or it increases to the X side. Okay. Then another one is when you have it as a negative, so less than, this sign just means that gradient, it's a negative. So that means if you have a negative 1, a negative 2, or a negative half, a negative 1/3, that gradient, then the graph will look like this, where the slope goes downwards. So it starts from here and it goes down just like that. So you need to be able to realize that as well, as remembering when you have your gradient as 0, that is a horizontal line, that is just y equals something. So this will be y equals a -4 graph, and that's how you get to your graph. Okay. Another one that we did was where we have a vertical line like that, where our gradient is undefined, and we did say that is where x is equals to something. In this case, our x equals 2. Okay, so this is just for you to recap and know what needs to be done. So before we do anything at this point, when you're settling and recapping properly, I would like you to then take a minute. Those who have the textbook called Spot On, they can then take their Spot On and they sit down and they check with me so that they have it. Those who don't have their Spot On, they can shop it right away online, or they can just take the screenshot of our page there, which is in page 195. So you can take, this is an example which we are going to show you how to draw the graph, because that is the lesson's focus for today. You need to know how to draw the graph. What do you need when you have to draw the graph? You need your pencil, your paper, your ruler, and your pen. So you need to settle down with water if you need to, so that we can spend this time together to draw the graph. I'll see you right back. Okay, I am very sure that we're excited to learn how to draw the graph, so let's do it together. Here you can see we are given an example where they say complete the table. So before you can draw the graph, you need to know we can complete the table, we can find the x and y intercept, then we can be able to draw. So you can choose whichever method. Here in our textbook, we have shown you what you can do in both methods. So we are given the equation y, let's just write it on the side. We are given y equals 3x minus 1, right? So for us to complete the table, what we need to do is to substitute the values that we are given as x values, which we literally call them the inputs, and then we get our output of y values. So here, my x is given to be a -3. So it means we're going to have y equals 3. So what is the aim here is that wherever we see an x, instead of us putting an x, we are going to put the number that is given, which is a -3. Okay, so we're going to put it like that. I prefer that you use a bracket because that will help you if there's a negative, so that you don't confuse it and say 3 minus 3, right? So put a bracket because bracket represent multiplication. And then we minus the 1 there, and then we'll have a 3 multiplied by a -3 will give us a -9. Then we have our -1, which when you add them together, you're going to get a -10. So that is why if you check here on our calculation, they did say that y equals 3, a bracket -3 minus 1, and then y equals -10. So this is the scenario or the procedure that they are following. Then when you get to your -10, you fill it there, which is what is shown here. Can you see that? So you have your -10, and then the coordinate format of that is going to be where x is -3, y is -10. So every time when we write the coordinates, we write them in terms of x and y. So this means x and y. It doesn't look so clear, so let me just write it. So that's x and y. We use the semicolon to say and. We don't use the comma, right? Because our comma, we use it when we are saying like 0,5, 0,2, our decimal numbers, we use commas. So here we're going to have x and y, which is a -3 and a -10. Those are our points that we need to have. Then if you go on and you just keep on putting the numbers there, when we put a -1, we're going to have our 3 multiplied by -1, which will give us an answer to be a -3. And then when we add a -1 to it, that's where we get a -4. So that is the procedure you're going to find. And you can see every time you get your answer, you then fill it in as an output or as the y value on the table. You do that to each and every one of those questions to get to the point where you have, when you put 3, then your y value is 8. You can see that, right? Then you write your coordinates like this. These are the points that we put into the graph for the graph, therefore, to look visible. So that's why we have it like that. Okay? So that's our graph. You can see, so that's the graph. What happened to the graph is that we have put the point a -3 and a 10. If you put -3 and 10 here, you're going to have this point, which is just down here. And then when you go, you put a -1 and the -4. So you're going to say where x is -1, y will be a -4. And that's why we have the point there. You can use your ruler, you can use your dot points while you have your Cartesian plane done properly. Just remember that in the Cartesian plane, always you have to label your Cartesian plane the x and the y values. So the y, this line is called y-axis, and this line is called x-axis. And when you are drawing, please remember to put your arrows in your graphs whenever you are having in the Cartesian plane, whenever you are drawing a graph. And also the graph itself, since you are drawing using a ruler, always have to have your direction to show that this is an ongoing graph. It's just that I have selected values from -3 to 3. So that is the only thing that is happening here. It doesn't mean that when you have it like that, then you have to get, you have to write it in a different format, right? So that is how you are writing it there. Okay. There we go. So that is what we do here to get to our graph. You plot it either by, so let's refresh. You can have your full complete table as a method of drawing a graph. That is our method number 1. And as you do that, you need to be able to put your coordinates together, right? That is one way of getting the answer. But now the other way that we can use, and which is what I'm going to show you on the other board, for us to get the same graph and for us to use another way to get to the one is where we use the x and the y intercept format. So I am going to write the same equation we have. So that is y equals 3x minus 1. So with this, if you remember in one of our lessons, we did say that whenever you want to calculate the x and the y intercept, you're going to do it this way. So for y intercept, I am going to let x to be equals to 0. That's what we do. So for y-intercept, we're going to let x to be 0. So what is going to happen here is that I'm going to substitute 0 wherever I see x. Let's do it together. So y will be equals to 3 multiplied by 0 minus 1. By now we should know that anything multiplied by 0 is 0. So then we'll have 0 minus 1, which means that our y-intercept is equals to minus 1, and its coordinate form. If I write in the coordinate form, I have 0 and minus 1. So that is my point. Then when we are looking for the second one, which is our x-intercept, so to get the x-intercept, I need to let y to be 0. So we're going to write for x-intercept, y will be equals to 0, right? Which means that whenever I see y, I'm going to substitute it by 0. So I'm going to have 0 equals 3x minus 1. But because I'm looking for x, what I'm going to do then is to move everything that is next to my x until it remains alone. So to move everything, what do? We're going to first add 1. But what we do on another side, we must do on the other. So that means that if I add 1 on my right-hand side, I need to add 1 on my left-hand side. So let's do that so that you guys can see. Okay, so I had 0. And then I am going to add the 1. Can see I'm using my yellowish color there for you to see that the relationship. So 0 plus 1, I will remain with 1. But then on my right-hand side, I have a -1 plus 1, which will give me a 0. So that means that on the right-hand side, I'm going to just have 3x. Then for me to remain with the x as promised, I would have to then divide by 3 to remain with the x only. But what I do on the right, I also have to do on my left. So that means that my point of x there will therefore be equals to, x will be equals to 1 divided by 3, for which the 3's will divide and I'll remain with 1. So that's how I'm writing it. And in the coordinate format, therefore, that means, remember, we are starting with x, then y. So it means we're going to have 1 divided by 3, and then we're going to have 0. So this is our coordinates of the x and the y-intercept. This is our y-intercept, and that is our, this is our x-intercept coordinate, and that is our y-intercept coordinate. You can see the difference here is that if you check on the first one, which is this one, y comes on the right and on the left we have 0. But if you check on the second coordinates, on the left we have x and on the right we have 0. So that's what makes it different in this case. But if you go to the graph and you check right here, let's see, if we just remove all this so that you can see only the graph. If you check the graph there, let's see. If we check our graph, you can see that right here, there is a point which is right here, a very small point. Let's see if we can give it a space for you guys to see. Zoom it in and then see if you can be able to see. So there's that point here where you can see that this is a -1, which is our point here. So where x is 0, y is a -1. There it is, right? Then where y is 0, x is 1 divided by 3, which is 0,333, something like that. So that is where it is, just here. So if you check, you can see that those 2 points are there. So what do? You would have used your points to draw. So what you do is you're just going to come here and then you mark it and then you come and mark there. Then you take your nice ruler, which you will have, and I do have mine. You take your ruler, then you put it just that way, and then you draw, joining with a ruler. So when you join those 2 points, they will automatically give you a full straight line. So that's how you use the x and the y intercept way of drawing. This gets easier as we practice. It does not just sound easier or you start with it and it's easy. You need to practice for it to be easy. This is supposed to be for you, right? Are we ready? You need to be able to look at this and then we do it together. So I'm going to do a few with you so you can see what we need to do, right? So let's do this one question and see the steps that we need to go through to get what we need, right? Here we are also given in this activity that we have a table that we are given an equation here. You can see that our equation is y equals 2x plus 1. And they want us to draw the graph on a Cartesian plane. But we need to then use a table to draw that graph. That is the first steps that we have done, where you can use a table. And then here we have decided. So this is the decision making. You can decide to start from a -5, or you can decide to start from a -2. Just don't decide to start from 0 because you won't have coordinates, right? At least give it 5 numbers for you to have a nice and smooth graph. So if you decide to start from a -10 to a +10, even better. If you start from a -5 to a +5, that is also better. But you can't start from 1 and then you have 0 and then you just have 3 points. Your graph might not be as accurate as nearly accurate as it should be, right? So here, you can see that you have your axis, which is given as -2, -1, 0, 1, and 2. We do the same. You just have to substitute. So yours is, you just take your equation y equals 2x plus 1, and then you substitute wherever you see x, the point. So we're going to show one example. Y will be equals to 2, and the first one I was given is a -2. Substitute by -2 plus 1. What will happen then? You'll have a 2 multiplied by a -2 gives you a -4. So you have -4 plus 1, which gives us -3. So you complete your table first. That will be your first step. Then the second step, then you're going to plot those particular points onto your straight line. You can plot them, and also while plotting them, you can actually just write them as coordinates. Remember, your coordinates will be a -2 and then a -3. So you go with them like that until you reach the last coordinate, which is a 2 and a 5. Just remember that your coordinates have a semicolon as your end, not a comma. So you plot them like that, you put them down like that, you go to your graph, and then you plot all those points as it is. So if you can check, for example, with these two, the -2 and -3, let's go check. So where x is -2, if you put your graph in the grid there, you will see that then y is -3, and that is your point there. Easy, right? So all these points that you have, will have them there like that. Where x is 2, y is 5, let's see. So where x is 2, which is this point here, if I put a ruler, I come here, I can see that my y is 5 there. So these are the points we are talking about. So you see, by finding those 2 points, by default, basically I can put my ruler and I can be able to draw my straight line graph very smooth and clear. Another note to take is that my gradient, therefore, it's a positive 2. Can you see my slope, how it goes? It goes from the left to the right, upwards. That's how the slope is going there because I have a positive gradient. Okay, so that's one. If you are given an equation then, and the question says write the x-intercept and write the y-intercept. So in some question you'll have the scaffolded way of the question. So scaffolded just simply means that they will direct you in what to do first. Here we are saying first write the x and the y-intercept. So the x and the y-intercept, how do you write them? The same way we were doing together. We said if you have it like that, you always have to let one part to be 0. So if I'm looking for y-intercept like this one, therefore my x will be 0. Then when I do that, that simply means that every time I see x, I must just substitute it by 0. When I do that, then that means that my y value will then be equals to 4. Do you see? So that is my y-intercept coordinate, which is 0 and 4. Easy, right? We do the same with our x. So we know that our coordinate, first one is 0 and 4. And we know our equation have a gradient of a -2, which means something. It means that our graph will therefore go this way. So it starts from up until down. So that is the difference. You can see that. And then moving from there, you can see again that for x-intercept, we let y to be 0. That is very important that when you are doing another variable, then the other one becomes 0. So if it's x, y becomes 0. If it's y, x becomes 0, right? But we follow the same procedures like as we did. So therefore, our y will then be substituted to be 0. Then I remain with my -2x plus 4, which what happened here initially, you will say, I had a -2x plus 4 equals 0. That's what I have. So for me to remain with an x, first of all, we're going to move the 4, but moving it means minus the 4 both sides of our equation. Then we remain with a -2x equals a -4. As soon as we have that, we will come then and divide both sides. Here they started by dividing by a negative, but we can just come and divide by a -2 both sides. And that will give us x to be equals to 2. Then we have our coordinate as 2 and 0. When you have that, you can actually use those two to then draw your graph. Voila! That is how your graph will look like. If you look at, you will see that we have our 0 and 4 point, and then we also have our 2 and 0 point. Your graph looks smooth and clear, just like that. Easy, right? You can do this with many, many, many questions, and you can get the solutions of them all the time when you're busy practicing, right? So I can just allow you to copy this because this is more for you when you keep on practicing. We need you to then learn how to plot many, many graphs, so you can take a screenshot, as well as this one where you have to determine the equation. We have shown you how you do that, and then you can be able to learn as many as you can. In our Platinum textbook as well, you can find many, many questions, which one of them is the one on the screen. It's taken from page 152. So in Platinum textbook, which is this one, if you have it, you can just go to your 152 and then you can actually answer the questions, or you can shop online with us in MML. Then you can be able to find many, many books and many, many questions. But if you get stuck while you are busy practicing with your previous question papers with any textbook, be it MML or not, Maski is there to help you. If you don't have Maski, please ask your parents to borrow their phone or use yours if you have one, even your siblings. Save this number 072 091 0388 and you just say, "Hi, Maski," and Maski will talk to you like a human being. It is designed for you to assist and make your education very easy and simple. I will see you next week. Hope you guys have enjoyed this lesson and you're going to use this as a resource to learn better and learn more. We at Maski Miller Learning and Maski TV and Teacher Thandi, we always love you and here to support you. See you next week. Bye.
And now we enter our next exciting chapter with the launch of Maskiverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.